Alright, so I'm going to give a quick rundown here of the difference in design between a basic furnace, a mid-efficiency furnace, and a high-efficiency furnace. So these are not to scale, obviously, but over here on the left, we've got an old basic furnace, right? So we had a pilot light somewhere that ignited the gas, and natural convection took the exhaust out. The old basic furnaces tended to have a small number of orifices that had a large amount of flame going through them, um, and they were quite a bit heavier, fairly small surface area wise in relation, and those. This is your combustion chamber here, right? Flames are going to happen in here, and then the natural convection of that heat would take our exhaust gases up through the flue and out the chimney. Okay. Mid and high efficiency furnaces, a little different. Instead of having a few big heavy tubes, they've got a lot more of those combustion tubes. They're lighter walled, they're thinner so that they can transmit heat better. That means that the flame inside each one of these individual tubes is a little smaller. So we've gone from a small amount of big flames to a large amount of smaller flames. We've increased the surface area on those heat exchangers so that more of that heat can be extracted by our fan. That's step one to making these furnaces more efficient. Right? We're just given more area to absorb for our air that the fan is blowing through to absorb that heat. You look at them from the side. This one, like I say, was natural convection. These were lit with a pilot light. Been through that. The mid efficiency furnaces and the high efficiency furnaces both use a combustion fan, which, as in the other video, showed that that's going to purge the gas out of here. It's going to prove that there is an airway, through the combustion chamber, through the flue, and outside. So we're going to have a flame-proving switch right here. What'll happen is, as long as that flame is moving, this is quite often just a sail switch, so it'll just flap in the wind. If this fan can't move any air, it falls back down to this point and reopens and shuts everything down. We're going to have an igniter in here somewhere, a flame proving device, and then our flame rollout device is going to be here. Okay, so those are all the components of it. Now, because we've got a fan on these, when this gas lights, we've got all this extra surface area to absorb heat. The other thing that we're going to do with an efficient furnace is that as the air comes through here and it burns, the hot air is going to naturally rise and sit along the top of this heat exchanger. They've made these heat exchangers a little taller, kind of a thinner tube. There's not actually any combustion that happens up in here. The combustion's in the middle, but some of the hot air gets trapped in here. As the hot air cools, it drops down to here, which is in line with the exhaust, and that fan is pushing that exhaust out. Okay, so whereas basic furnaces used natural convection, and it actually needed the exhaust gases to be hot to get those exhaust gases out of the house. Here we're trying to cool off the exhaust gases as best as we can and then physically force them out of the house by the use of that combustion air fan. So that was a mid-efficiency. Like I say, they didn't last very long because shortly after they came up with this mid-efficiency design, they went to the high efficiency, which simply added another coil in here that exhaust gas circulated through, gave it a little more chance for the the main fan, which is blowing air across it to extract all the heat out of that, and that took the efficiency on those from in the 80% range up to the 95, 98% range. Okay. The other thing when they went to a high efficiency furnace from a mid efficiency furnace is that we had to add a drain pipe on them because anytime you burn anything, it releases a little bit of water vapor, right? Wood, very, very small amount. Coal, a little bit more. Gasoline, diesel fuel, natural gas, propane, more yet, right? We've all seen water drip out of the exhaust pipe of a car. There's always some water vapor both in the air or in the materials that we're burning, and we got to get rid of that. So they put it on a high efficiency furnace because there's water vapor that's created, or the water, it's not water vapor, it actually condenses. That's where the term high efficiency or condensing furnace comes in. That water condenses, and then we have to drain that out and put it into a floor drain. Now, when they first started to come out, people didn't know a lot about them. They used to just run this pipe down onto the floor onto the floor. If it was within a foot or so of the floor drain, they didn't worry about it. Problem is that 3 or 4 months later, after these furnaces got put in, after partway through the first winter, they noticed that all the concrete where that water was draining out, all the concrete was eaten up.